Hello guys, this video is going to be all about queue data structure, and we will go through this four main basic stuff. First one is theory, the second one is folder structure, the third one is implementation of the queue in code via C++, and the fourth one is testing all those code in main.cpp. So we'll go over these four main points, and we'll firstly start with theory. Okay, so to start with theory, let's just first understand what is a queue. So suppose there is so let's say there is counter a counter for, let's say, uh, that's a bank counter. So for it, let's say this is the bank counter and you are standing up in a line. Okay, so there is a huge line of peoples who are standing in front of it, and the bank counter, the person who is sitting at the bank counter, he's just taking your checks and giving you the money. Okay, so this is the main thing about this. So let's just put some peoples in front of the counter. So this is going to be peoples. Okay, 3, and there is last one is 4. Okay, so now let's go through one of them. So this is, let's say, is A, the second one is, let's say, B, the third one is, let's say, C, and the last one is D. Okay, so these are the peoples which are standing in line in front of the bank counter. So basically what they need to do is they will give the check to the bank counter, and bank counter will proceed with the money and give the money back to A. Okay, so as I mentioned, they are standing up in a line. So queue actually works like that. So basically everything is kind of like a, you can think of it like a linked list or array, and in the implementation you will see we can use both of them. Like we can use array, we can use linked list also. I'm going to use linked list, but the point is uh, so if you think each of these people will do their job, like give the check to the bank counter person and they will give back the money. So how it's gonna work actually? So basically they are facing towards this direction, they are going towards this direction, right? So the bank counter direction. So what is happening is, like, if this A person goes to this bank counter, okay, and now the bank counter proceeds with the request from the person A, and they finish the job. So the bank counter person finishes the job of the person A. So after the job is done, what the bank counter is going to do? He will remove this person A from the line. So now the B comes first, right? So now the A is removed from here. Okay, so A is gone. Now the person B comes in the place of A, right? So basically B comes in the person place of A, C comes in the place of B, and D comes in the place of C. Okay, so now the same thing happens. The B proceed with the process of giving the check back to the bank counter, and bank counter will proceed with the money. So the same process. Okay, the same process continue. The queue just works like this. So if you think this people as node, okay, so now think of this bank counter as a null pointer. Okay, so now what happens is, so suppose all of this queue is linked. Okay, all of these nodes are linked together, so it is performing a linked list. Okay, so the first thing is it's performing a linked list. Okay, so you can see this is a linked list where you can add people at the last place. Okay, so you can add persons in the last place, and person defines here as a node. So you can add a node in the last place. So let's say I'm adding a new node which is E, and now this is going to be pointing towards the D. Okay, so now if the E is pointing towards D and the new people is added in the line, okay, so now the same thing happens. So if the work of B is done, then what we are going to do is we are going to remove B. Okay, so we are going to remove the node B, and now what I can do is we can just put the C in place of B. See, so this is how a queue is going to work. It's going to add a node from the back of the list. So you can say it as a top in the sense of stack, and you can say it as the last node in the sense of normal linked list. So the first node is always going to start at the node that is going to be added in the linked list. So you can think this whole thing like this. So whenever I'm adding a new node, it's always going to be added at the beginning of the linked list. So this is the beginning of the linked list, because queue directly works like that at the beginning of the linked list. And whenever I'm going to remove anything from the linked list, we are going to remove the we are going to remove the node which is at the last position. So in this case, the C. So after the work of C is done, we are going to remove this C. So there we have concluded two things. So there is one function which is basically enqueue, and there is one more function which is dequeue. Okay, so these are the two main functions of queues. Okay, so what is enqueue? Enqueue is adding a person to the line, which means adding a node to the line. Where is this node going to be? It's going to be at the beginning of the linked list. And dequeue means removing one person from the linked list. So it means I'm going to remove one node from the linked list. So this is going to be the last node. So this is the two main functions of a queue. And sometimes you can find some boundary limited queue, which are basically have a restriction on how many nodes a linked list can have. Okay, so in that case, the linked list, let's say the linked list only can have 10 nodes. So in that case, the linked list is going to be containing only 10 nodes. After the 10 nodes, you cannot add anything in the linked list. Okay, this is one part. Okay, so now let's go to how this enqueue and dequeue function is going to be working. Okay, so let's first go to the enqueue function. So what we're going to do is we're going to firstly create a new node, fresh node. Okay, so this is our fresh node. Okay, so this is going to be our fresh node, and what we are going to do is we're going to put the data inside this, right? So let's say data. Now I'm typing just like this. Okay, sorry, let's just delete it, and let's for now let's also delete this. For now, let's just add data in here. And so this is going to be our node, newly created node, new node. Okay, so this is going to be our new node, which we are going to create. And let's say this is our rest of the linked list. Okay, so this is our rest of the linked list. What we are going to do is we are going to take the pointer which is pointing at the beginning of the linked list. So the beginning pointer, which is actually pointing to the beginning node of the linked list. So the starting node ptr. So you are going to take this node this pointer, and what we're going to do is we first will point this new node to the beginning of the linked list. Let's point it to the beginning of the linked list. And then what we're going to do is we're going to take this starting node pointer and we'll move it to the new node. So now this pointer should point to this new node, right? This is done. So this is basically the enqueue function where we add a node to the queue, and the next function is, say, the next function is dequeue function, right? So what we're going to do in the dequeue is, so let's say there is this linked list, and for now let's say I'm going to select this one. If I can do that, yeah. Okay, I cannot. Okay, so this is the linked list without the last node. Okay, this is the linked list without the last node. So let's denote the last node as L. Okay, last node as L, and the linked list is pointing towards this node, and so this node is pointing towards what? This node is pointing towards null, right? So let's just add a huge null. Okay, this is pointing towards null. So as I said, when we remove something, we always have to remove something from the last place, right? So let's remove the last node. Basically what we are going to do is we are going to iterate everything from the start. So there is a pointer called starting node pointer. So let's just add SNP for starting node pointer, and this is pointing towards the beginning of the node, so at the beginning. And now what we're going to do, we are going to create a new pointer which will be pointing towards the new beginning node. So let's say we'll name this pointer as ITR because it's going to be a iterator pointer. Okay, good thing. So now what we're going to do is we're going to point it at the starting node. So we'll iterate over this whole linked list and we'll go to the previous node of the last node. So the previous node from the last node. Okay, so now this iterator should be pointing towards this part, right? This last node. Okay, so this is going to be pointing towards this last node. Okay, good thing. Now what I'm going to do is I'm going to point this iterator's next node to a null node. Null. Okay, so in that case what it's going to do is, so it's going to remove this thing and it's going to point somewhere else. So that is going to be our null pointer. And now we are going to do is we are going to remove this new node from the linked list. So that's how we are going to perform the dequeue function. So this is the procedure for the dequeue function. And let's just talk about how the queue is actually used in a real life scenario. So in real life, suppose in a OS scenario, so there is a OS operating system. So in that case, so suppose it is programmed as like performing which process comes first will get executed first. Okay, so whoever comes first, they will get executed first. That is the motto of standing in a line, right? So if you stand before some person, so your priority will be higher than that person, right? You will get your process done before that person who is standing behind you, right? So that's how it's going to work in the queue. Queue is basically implementing that stuff. in a programmatic way. So in process execution, priority ordering, in those kind of cases, queue you use. So there is another data structure called priority queue. If you read about that, you will know what I'm talking about. So there is something called priorities. Every node has its own priorities. So in that case, that becomes a priority queue. Okay. So these are the real world scenario. So I'm only giving you an example, one example, which is the OS process execution example. You can think of it like that. So as we go through over the like two functions, enqueue and dequeue, these are the most important function for a queue. After this, we will go to the folder structure. Okay. So see you in the next part. Okay, welcome to the next part where we're going to implement the folder structure for the queue. So let's begin. So firstly, what I'm going to do is let's create a new branch for this. So get branch and let's name it Q. Okay. So it should create a new branch. Okay, so there is Q, our Q. So let's move to Q. So git checkout Q, and we're inside Q. Okay. So now let's create a new folder. So where are we? We are at the root directory. Okay. Or the main directory. Okay. So let's create a new folder mkdir QUV. So that will create the new folder. Okay. Let's go to Q. Okay. Okay. Now we are in. So in here, so the first thing I'm going to do is we will need the node implementation of node. Let's just copy that, and we'll also copy the make file. Okay, so let's just go back one folder. Sorry. Okay, let's let's copy cp stack, and then we're going to copy node dot header file stack. Let's copy multiple things. So let us not do it in one go. QUE, and yep. Okay, let's copy the cpp file. Cpp. Okay, let's also copy the make file. So what I'm going to do is I'm going to remove this and make a make file. Fine, and I'm going to copy that also. Okay, so everything is here. Okay, so that should be it. So let's go back to the queue. Yep, all of these things are here. So let's just quickly create everything we need in one go. Okay, so the first thing we'll set this up, no worries, but for now let's just go to here and let's create a new file which is going to be q.h, which is the queue header file, and we'll create another file QE.cpp where we'll define everything. And now let's create another file which is main.cpp. Okay, it's done. So let's just fix our makefile first. So the makefile should have main.o, which is we will not have stack.o, we'll instead will have a queue object file, and we'll have node, and in place of stack we'll have queue. Okay, there is that. And main.cpp will be just like that. There will be no stack.cpp dependencies. We'll have queue instead that. Okay, so here also is going to be queue. Okay, and node will be node, clear will be clear. Okay, this is also going to be queue. Okay, so there is this output which is working now. Okay, main is also, queue is also set up. node is also set up. Okay, so this is basically our folder structure for implementing queue. Okay, we'll go to the next step where we will start implementing the queue from scratch. Okay, see you in the next part. Okay, let's start with implementing queue. Okay, so the first thing, let's see what we will need. So the first thing we will need is, so there is this, we have to create a new node for enqueuing function. So before enqueuing, let's just get one thing done. So we'll need a starting node pointer ptr, or let's just call it for now head pointer, which is going to be pointing towards the head node of the linked list. Fine. We'll need a enqueue function, which is going to return a integer, only going to return integer, which will not accept any kind of parameter or argument. So enqueue. Okay, done. So this is a function. So to identify this is a function, let's just add a plus. This should do it. And now let's just copy it one more time, and there should be this dequeue. Okay, so these are the main three fundamental things that we need actually. So there's going to be a head pointer, there's going to be an enqueue, there's going to be a dequeue, and one more thing I am going to add is, so there's going to be a print function, which is not necessary, but I'm going to do it anyway. So there's going to be a void print, which is not in part of a the part of a queue or data structure. I'm going to make this function to test everything. So let's start with implementing this. So let's get to the code. So let's jump in. Okay, so let's open up our queue.header file. So first let's include our main node header file. Okay, this should allow us to access our nodes. Okay, now let's make a fndef. So let's name it queue dot header, and let's also define if not there, so queue header. Okay, and we should also make a endif. Okay, so let's implement class. So it should take let's name the class queue, and let's start implementing this. Okay, first thing first, what it's going to do is, so let's first annotate some things. So private variables, we don't need private variables actually, but we can take private variables. No, we don't need private variables. So everything should be public variable, and here it's going to be a node pointer, node ptr. Okay, so let's name this a head pointer, head pointer, and there should be a enqueue function, enqueue. Okay, enqueue function. Okay, and there should also be a dequeue function. Oh, one more thing, this enqueue and dequeue function is only going to return the value it will add or it will remove from the linked list. Okay, and lastly there is going to be a void print. Okay, so this looks almost ready for the structure. Oh, one thing I forgot to add is this. Okay, so this will be our queue header file. It's going to have a pointer to the head, and it's going to have three functions. One is print and the other two is enqueue and dequeue. Okay, let's implement this in the in our cpp, and let's define all of them. So firstly, let's add all the things we need. So the first thing first, we will need the node header file, and we will need the queue header file. Okay, this should suffice. So let's first implement enqueue. Okay, so I have to mention I'm going to be defining the queue function for okay, this one. So yep, let's do this. Okay, so the first thing first. Okay, one more thing I just forgot. So we also want like to initialize our linked list when we will be calling our queue, right? So let's give a constructor to it. So the constructor should be queue. Okay, it will accept a integer value. Okay, so this should be it. So yeah, and now let's go to our CPP. So let's first add our constructor. Okay, okay, it will take a int value and it should do one thing. Okay, so first thing it should do is it should create a linked list, right? So new node, node star ptr equals to new node, and it should point to value, right? Done. Pointing to value is done, and then we are going to add this new node and point our heads toward this node. So head should be pointing towards the ptr, sorry, which should be like this. Okay, so everything is ready. Our linked list is initialized and now it's working. So let's add enqueue function. So what's enqueue gonna do is, so enqueue will basically create a new node first, because we are adding a new node. So new node, and it should be a new node. Okay, now I remember one thing. So yeah, basically we need actually value. We have to pass value inside enqueue. Otherwise, how we're going to add a new node without any kind of data? So that should be it. Yeah. So let's give it a int value. So now this node should accept a value. Okay, so this will be this value. Now the new node has this value. What it should do is now the new node next pointer set next node address should point towards the head pointer, right? This linked list head pointer. Okay, so enqueue, always remember enqueue is adding a new node to the top of the to the front of the linked list, right? So yep, this is what we are going to add. Oh, one more thing, let's just return the value. Okay, now what we are going to do, we will update our head pointer, right? Head. Yep, so let's update it to new node. Okay, this looks fine. So this is our enqueue. Let's add our dequeue. Okay, so this shouldn't accept anything because it's going to remove a new node. So firstly, let's iterate to the previous of the last node, previous node of the last node. Okay, so how we're going to do that. So for now, let's create a new pointer, node star, iterator, uh, iterator equals to this head, right? This should point to the head of the linked list, which is the first element. So now this should go to the previous node of the last node. Okay. So let's go to the previous node of the last node. So if I write in this while condition that iterator's last node, iterator's next value, get next node address equals to not equals to null, okay, that way it will reach to the last node, right? If I write this one, so let's just go back to our etc. We'll see. So suppose we are iterating through everything, we are iterating one by one every node. So the while condition was until the iterator's next node becomes null. So what is the node that's next node is null? So the last node is always the next node. The last node's next node is always null. So it is going to be stopped at the last node. So in that case, we don't want the last node. Instead, what we want is we want the previous node of the last node. Okay. So let's get back to the coding. Okay. So in this case, so let's just add one more thing. So this whole thing, iterator to this get the next node address, this should return me the last node, right? So what I'm going to do is I'm going to draw out one more node before this node. Okay, so let's put one more thing, get next node, guess next node address. Done. Yep, this is done. So iterator get next node address should point to the previous of that node, right? Iterator get next node address and the previous node. Okay, what this is going to do is this thing, the first part, get next node address, should return the previous the next node address, right? So this should return the last node address, and the last node address get next node address should return null when the iterator should be the previous of the last node. Yeah, this should work. We'll see in the runtime. So let's see. Let's add all those things that we need. Now what we need is, so say the first thing, let's do one thing. So update the iterator, right? Okay, iterator should be get next node address. Okay, fine. So we are updating the iterator. We don't want to do anything other than this. And the next thing should be value. So let's store the last node's value, which we are going to remove in this part. Okay, so let's add the next node address, and we're going to fetch the data from this address. So remember, the iterator is now stopping to the previous node of the last node. So if we want to access the last node, we have to get the last node address. So this is the first part. Iterators get next node address should return the last node address, and from this node we're going to fetch the data that is stored in there. Okay, so this should give the data back. Okay, after this, let's update our iterator. Okay, iterator's next node address, set next node address. So this should point to null pointer. Okay, and let's just return the value. Okay, so this should be our dequeue function. After that, the print function is very basic, the same iterating thing. We're going to iterate over the all the nodes that's present in that part. Okay, done. And let's do one thing. Node star iterator this head this part. So then now we will create a new pointer which will be pointing towards the head. We'll update this, reaching to the very end of the linked list. So this one, until this is becoming of null, we'll iterate through everything. Okay, so now this should give me a std out, and iterator's value should be printed. Oh, one more thing I just forget to mention. I actually implemented everything in the previous video, and after implementing everything and recording everything, I just forget that I forgot to change the scene. So it was always in the Elixir draw and I was just talking in the mic. So yeah, I'm really sorry for that, because in that scene, that part, you can see that there was no include iostream. So I included in that part. Okay, so yeah, yeah, so I'm just doing that once again, one more time. So yep, so we'll get the stored data and we'll print a space separate like this, and we will update the iterator's value. Iterator equals to iterator get next node address. Yep, so this should update the iterator. And now let's also give a new line. Yep, this should work. Okay, so now we are going to go to the testing file. This should be pretty much clear. Okay, so this is what the testing file should have include, and this should be iostream. And okay, and after that there should be int name basic setup. So, and also we are going to return 0. Yep. And now just let's go and implement some things in here. So the first thing we want to do is we want to include those files. Include first file is the queue header file. Okay, and the next part is let's pull out our queue. Let's name our queue very small thing. Let's name our queue A for now. So queue should be like this. So let's start our queue with value 5. Right now the queue should contain 5, and let's first test something. So the first thing I'm going to do is I'm going to enqueue a value. So let's enqueue 43 for now. Remember, this is going to add this 40 to the beginning of the queue, right? So let's just also do a print statement, right? Done. And let's just perform a dequeue. This should be it, right? So one also print, right? Okay, so in this to stuff, okay, so yep, let's check our make file. This is going to be very basic. It's going to contain 2 nodes and it's going to perform all the stuff in this. So okay, I don't know why our make files ms small. I suppose when I'm copying that, it should be like I copied that with a wrong name. So let's just rename this. So I'm going to rename this only to the file. Okay, file already exists. Queue make file, why not? Okay, so I suppose that's a bad thing. Oh, okay, we will see renaming this whole thing. So let's make file. We cannot rename this because it's saying that file already exists. Okay, we will see. So for now, let's see what happens. Okay, so let's do a make. Okay, so firstly it's printing 43.5 and now it's printing 43, which is good because if you remember, let's pull up our editor. So where was I? I was in like the main.cpp. So in here we firstly added 5, which is at the very beginning of the queue, and after that we enqueued 143. So this should be added at the first, right? 43.5, and after that we made a print. So it's going to print like 43.5. So that's the first value, first line. And after that we performed a dequeue, which is removing a node from the last, and it's removed the node from the last 5, and now it's only content 43. So that is the printout. Okay, and one more thing I just forgot to mention. If our queue doesn't have anything, so we cannot dequeue, right? So let's just make a condition for that. Let's put a condition in the dequeue. So we will check. So we will check if so in dequeue what we are performing is we are removing every value, and are we updating the head? Okay, we are not. Okay, so the head is always pointing to the first node. If we remove everything, so there isn't anything, right? So let's just tackle it with a simple thing. So let's just add a size. I know this is a very cheap way, but yeah, let's just do it like this. So there should be size. So whenever we are adding something, let's just update our size, right? So the size should be now 1, right? Done. Okay, so we didn't save this. Okay, so we should save this. Okay, done. We are in enqueuing everything, so this should also update. The size should be ++, and when we are dequeuing anything, the size should be -. So it's a minus. Okay, sorry, you have to put up this. Okay, so now the size is getting updated. So what I'm going to do is we'll firstly check if our size is this size, the total amount of node is 0 or not. If it's 0, we are going to return. We won't do anything. We're just going to return 0. Okay, for now let's not return 0, let's return -1. So this should fulfill that criteria. So if I make 2 more dequeue, right? So if I make 2 more dequeue, so it shouldn't do anything, right? So let's just go to our main.cpp and let's just update it. Okay, so now this whole thing queue contains only one element, which is 43. So let's just remove that dequeue. Okay, they should remove it, and now our queue doesn't have anything. So if I make like dequeue again, so it shouldn't do anything. Now if I make a enqueue, it should only contain this 77, right? Okay, so how to know? We're going to print it. Done. Okay, so let's test it out. Let's make it again. Okay, there is an error. Okay, good thing. Output error. minus, which is we have to check. I made something wrong. Okay, let's check. QCPP, is it saved? Yep. When the size is equals to 0, let's return -1. It's good. Okay. So how is this happening? So when the size is -1, and then adding a new node, we're updating the value. Okay, that is good thing. Okay, declared null and all those things are declared. So now, okay, we enqueued a 77 in here. After removing everything, it's going to return -1. It isn't going to perform anything. It's going to only perform. Okay, that is good. Up till this point is fine. So let's check by doing something. Okay, let's remove this and let's run. Make again. This should work. Okay, this is not working. So the main function is we are mainly having problem with the dequeue, right? So let's just check the dequeue once more. So what we're doing is we're checking if the size is equals to 0, it reaches 0, so it should return -1, right? So let's do something. Let's check if it's coming in here or not. So let's do a standard output. Out Q is already empty. Okay, let's give a new line in here. Okay, this should work. And also let's not do anything, and let's do a return 0. So let's see what happens. Okay, so now it is like this. So let's quit and let's check. Make again. Okay, it's giving error again. So the output is error. Okay. So let's check what we are doing wrong. We are enlisting a 1 in here. Okay, this is good. Whenever we are enqueuing, we are just updating the size. That is also good. When we are dequeuing, we are minusing the size. Good thing. But what is actually happening? So suppose for some reason, let's not return anything. Let's just pass. No, there is nothing like pass. So we have to return something. So let's return. Let's return an arbitrary value, 1900. I don't know what's happening. So if our size becomes 0, okay, so less than equals to 0. So let's return this. So let's check if that is because we are not making. Okay, no, that's not the problem. So the problem is somewhere else. So where is this? So Q is already empty. The size should be in here, which is less than 0, less than equals to 0. If it's less than equals to 0, the size, then we'll print out a Q is already empty. Okay, and we'll return a 1900. Okay, I don't see a problem with this. Okay. So what we're doing in the main file, let's see. The linked list contains one element 5. After that, we contains two elements 43 and 5. 5 is pointing to null. Good. Done. Dequeue. In dequeue, what we're doing is we are removing 5. So now the 43 contains and 43 is pointing to null. Good. After that, print. So the 43 is there still. This is good. After that, we run a dequeue. So if we just comment it out, this should work, right? So if I make, it should work. Okay, it's also not working. I don't know what's happening in there. So for some reason, if I remove even the last one, then it's not working. Okay, I have not checked that part yet. So suppose we are at our last node. See, our linked list contains only one node, which is pointing to null, and the head is pointing to that node, right? The head should be pointing to that node. What if I'm removing the last node? So okay, so now only the 43 contains. Head is pointing to 43. So if I dequeue that 43, the size is not 0 yet. So it should go to this line 26. It will create an iterator, which is head. Okay, so this is what messing this up. So now this thing, okay, hold on. This thing, iterator get next node, is actually this part is actually returning null, and null cannot have this property get next node. So yep, that's the thing where we messed up. Okay, so also we have to set something like when there is only one node, we are not going to perform this action, right? So in case where we have one node, so the size should be 1, right? Okay, that is good thing. Only when we have two nodes, this case is going to work. Okay, so this node should be pointing to the first node, and then this part is going to pointing to the next node, and this should be the next node's next value, which is null. So the iterator should stop at head and remove the first part. Okay, that is good. So we have to update this part, right? So executing this while statement, we should at least have one node, right? So the size should contain at least one. If the size equals to 1, then we are going to perform this part, right? So let's add this. Okay, if our value is not 1, okay, if our value is not 1, in that case, okay, if our value is not 1, in that case only we are going to perform this. And in other cases, what we're going to do is, if the size value is 1, then else we don't have to actually do anything. So if, remember, if the node is 1, there is only one node exists, in that case we have to update the iterator. Other than that, we don't have to update the iterator, right? If there is only one node, okay, so if there is only one node, in that case we don't have to update the iterator. That one node should be the head node, and the head pointer should be pointing to that first node, and the iterator is also pointing to the first node. Okay, good thing. So now we also have to update this one. So let's just delete it and let's just add it in here. So let's pull it back. So now let's p and let's add it in here. Okay, done. And in other cases we should do else. Now we need a else because we have to get the value, right? So let's do a else. We'll initialize another value, and this should be iterator iterators. In case where we only have one list, one element, in that case we'll just return the get stored value. Okay, this is, I think, it. So now we'll get everything from this. Okay, so this should probably work. So let's see one more time. So if there is only one node, then we are going to skip everything. We're going to come to this and we will initialize the value. We're going to update the iterator's next node address to null, which is the head's next node address to null. The size minus minus. Okay, we are actually not removing the head. So in case where the value is not 1, we'll do everything in here, right? So let's remove this one and also print it in here. So yep, and in this case what we are going to do is, let's update the head should be pointing to null, right? Okay, if there is only one node and we are performing a dequeue, that node should be eliminated and the head should be pointing to null. This is clear, and after that we'll update the size in every cases. This is done. Okay, so this is it. This should do most of the part. It's done. Okay, value, we'll get the value in every cases. So value, did you mean false, fix available? Okay, so undeclared identifier value. Okay, we are not actually accessing the value. So for now, let's just see if make is making any kind of weird thing. Okay, so it's actually not getting the value. Okay, that's a problem. What we have to do is we have to check, right? Okay, so let's just do one thing. Let's just make a redundant policy like this. Also make this size should be updated minus. Okay, and this should also be added to in here, right? And after adding this, we should also return value. Okay, so this should be it. And now let's check if this is working or not. See. Okay, so yeah, you see, for now it's not returning anything, but it's also not making any kind of assumptions as first it was doing. So now let's check our CPP. So now we have two elements, we are dequeuing both of them. After that, if we open up this one, so let's save, wait and make again. So see, now it's giving me queue is already empty. Okay, this is a good sign. Now it should work as it should be. Okay, so if I remove both of the comments, okay, and save, this should work. And let's make again. Okay, see, so now our queue is containing only 77 in here. Yep. Okay, this is good. Okay, so this was the whole implementation and test. I know I have made some mistake and I took some time to find the problems. Thank you for watching. We'll see in the next video. Okay? Thank you.